Welcome back to the channel. In today's lecture, we are going to discuss the Wien Bridge Oscillator. Before going into the circuit and mathematical derivations, let us first understand what an oscillator is. An oscillator is an electronic circuit that generates a periodic signal such as a sine wave without requiring a continuous external input. Among different sinusoidal oscillators, the Wien Bridge oscillator is widely used because it can generate a low distortion sine wave with a simple RC network. So let's understand the basic working, derive the frequency of oscillation, and finally find the condition required for sustained oscillation. Before going into the Wien Bridge oscillator, we should know a few basic concepts. The first is feedback, where a portion of output is returned into the input. For oscillation, we use positive feedback. The second important concept is Barkhausen Criterion, which states that for sustained oscillation, the loop gain A beta should be equals to 1 and the total phase shift should be 0 or 360 degrees. In Wien Bridge Oscillator, an RC network is used as frequency selective feedback network while the amplifier provides the required gain. So this is the circuit diagram, and we take a portion from this circuit and put it into the right side for calculation of feedback network. So the amplifier gain A is equals to 1 plus RF by RG, right? And we know the feedback gain is equals to beta is equals to VFB by V out. So now consider the two things, that is Z1 is equals to R1 plus XC1, and as the R2 and C2 are in parallel, so we can write it as Z2 is equals to R2 XC2 by R2 plus XC2. And from the basic fundamentals of a circuit, we can write VFB is equals to, from the voltage division rule, we can write VFB equals to V out into Z2 by Z1 plus Z2. So now we just put Z1, Z2 value in the equation, and we can write it as VFB is equals to V out into R2 XC2 by R2 plus XC2 by R1 plus XC1 plus R2 XC2 by R2 plus XC2. Now just simplify this equation and we can get V out into R2 XC2 by R1 R2 plus R2 XC1 plus R1 XC2 plus R1 XC1 XC2 plus R2 XC2. So we know the value of XC1 is equals to minus J by omega C1, and xc2 is equals to minus j by omega c2, right? So putting the value of xc1 and xc2 in the equation, so we can write it as VFV equals to V out into R2 minus J by omega C2 by R1 R2. From XC1 XT2 we get minus 1 by omega square C1 C2 minus R2 into J by omega C1 minus J R1 by omega C2 minus J R2 by omega C2. So now separate the real and imaginary part in the denominator. So just copy this and paste it in the next page. Yes. So VFP is equals to V out into minus R2J by omega C2 by R1 R2 minus 1 by omega square C1 C2 minus J into R2 by omega C1 plus R1 by omega C2 plus R2 by omega C2, right? So the numerator have the minus j terms, that is minus 90-degree phase shift. So the denominator also have the minus 90-degree phase shift in all terms. So the real part should be equals to 0 to get the minus 90-degree in the denominator. So the real component is equals to 0. That is R1 R2 is equals to 1 by omega square C1 C2. That is omega square equals to 1 by R1 R2 C1 C2, and omega equals to 1 by root over of R1 R2 C1 C2, and from that f is equals to 1 by 2 pi root over of R1 R2 C1 C2. So this is the frequency of oscillation for Wien Bridge Oscillator. Oscillation. So now, if the real part equals to 0, then VFP by V out is equals to R2 by omega C2 by R1 by omega C2 plus R2 by omega C1 plus R2 by omega C2. So now here we can calculate the value of beta by cancelling out the omega from numerator and denominator. So beta equals to R test C2 by R1 by C2 plus R2 by C1 plus R2 by C2. So this is the value of feedback gain in Wien Bridge oscillator. So from the Barkhausen criteria we know that A beta is equals to 1. So A is equals to 1 by beta. Previously we calculate the value of A, that is 1 plus Rf by Rg equals to 1 by beta, that is R1 by C2 by that is C2, and R2 by C1 plus R2 by C2 by R2 by C2. So Rf by Rg plus 1 equals to, cancelling out the common part, that is R1 by R2 plus C2 by C1 plus 1, cancelling out the value of 1, and Rf by Rg is equals to 1 R1 by R2 by plus C2 by C1. So this is the condition for sustained oscillation in Wien Bridge oscillator. Condition for sustained oscillation. That's all. Thank you for watching. If you found this lecture helpful, please like, share and subscribe to Semicode. The PDF of today's slides are available in the description below. See you in the next lecture.